There we go. All right, 5, 3. So we're going to start with a few trig properties, mostly today, other ways that we can find some of our trig functions, and then if not today, for sure tomorrow, we're going to get the rest of your unit circle filled out and talk about how to use it. Will be kind of the goal of this lesson today, all right? Okay, so we're going to start with alternative definitions for our 6 trig functions. I need you to draw this picture in your notes, please. That right triangle. Okay, so that right triangle represents any angle drawn in standard position. So we're thinking of that x-axis, that positive side of the x-axis is the initial side of our angle, and then we have a positive rotation counterclockwise, and you can see that with the theta in the middle there. This one's pictured in quadrant 1, but really that rotation could go into any quadrant. If we pick a point on what we call the terminal side of the angle, wherever it stops, and they're using the point xy here. From that point, we can create an altitude, which if you remember that from geometry, that's a fancy way of saying a line that makes a right angle with whatever our base is. In this case, it would be our x-axis. And we can also connect it to the origin, which forms a right triangle you can see in this picture. Labeling our sides, if that point is xy, x would be my left-right side, my left-right leg, y would be my up-down leg, and then the hypotenuse we're labeling with r. R is eventually going to represent the radius of a circle, so that's why they're using that variable. From this picture then, if you use your SOHCAHTOA ratios, you get those 6 formulas on the side. So if I wanted to find the sine of theta, I would do the opposite over the hypotenuse, which you can see is y over r. So that's what that is. Adjacent over hypotenuse, x over r gives me cosine. So write those 6 ratios down. You don't need to write the x can't equal 0, y can't equal 0 stuff. That's just saying if you divide by 0, it's undefined, which we know that already, so it's not really worth putting in your notes. Okay. When we define it like this, now we can talk about angles that aren't necessarily acute. They can be in quadrant 2 or quadrant 3 or quadrant 4, and we can get the same picture. And then my x or my y could be negative. So we're going to now start having sines and cosines and tangents that are negative values. Everything won't always be positive anymore. Okay, so you're going to see problems like this in your homework. It says, suppose theta is an angle whose terminal side contains the point 2, -5. Find the exact values of the 6 trigonometric functions. All right, so we're going to draw a picture to help us with this. I'm just going to draw an axis. Okay, and I'm going to sketch that point. That's the point 2, -5. So I'd have to go right 2, down 5. Not necessarily drawn to scale, but it's going to be somewhere in quadrant 4. Okay. From that point, we're going to create an altitude, so a line connected to the x-axis. That is going to form our right angle. Your right angle will always be on the x-axis. And we're also going to connect our point to the origin, and that creates our right triangle. The theta that you're using, technically the theta is this rotation, okay? But according to this theorem above in this little picture, we can use an equivalent angle on the inside, which sometimes we call it like theta prime, a little theta with a little, looks like a number 1 up in the exponent, that will give us equivalent trig values, okay? Now the point, it was 2, -5. So I can label 2 of my sides. My x-axis, so left, right, is 2. My y, my up, down, is -5. And then we can always get the hypotenuse by using the Pythagorean theorem. So this is probably a quick little like mental math, right? 2 squared plus 5 squared gives me 29. Take the square root of it. The hypotenuse is rad 29. Okay, now you're ready to find all 6 trig functions, starting with sine. Now you can do this 2 different ways. You can, once you have the picture, think about it as opposite over hypotenuse, or you can use y over r. We have our y, we have our r, you can divide them. Either way, you're going to get the same answer, okay? So opposite over hypotenuse, or y over r, gives me -5 over rad 29. And if I rationalize that, I would multiply the top and the bottom both by square root 29. So I'd end up with -5 rad 29 over 29. Cosine is adjacent over hypotenuse, or x over r. 2 over rad 29, or 2 rad 29 over 29. Tangent, opposite over adjacent, or y over x. -5 over 2, and that one does not need rationalized. And then our other 3, you can again use the definitions, or once I have these, I like to use those reciprocal functions, where we know we just flip it. Remember, work smarter, not harder here. So we could flip these ones, but we have a radical in the denominator, so I'm going to use the first version we found for sine and cosine there. If I flip -5 over rad 29, I'm going to get rad 29 over 5, and you can put the negative anywhere you want. I'm just going to put it out front. Secant, reciprocal of cosine, would be rad 29 over 2. And then cotangent, reciprocal of tangent, -2/5. Okay? Any questions? Okay, so we plot the point. We connect the point to the x-axis, connect the point to the origin. That forms the triangle that you need to answer these questions. All right. So now let's talk about how we know what's going to be positive where, now that we're including these negative signs. You don't need to write all of that down. What I would put in your notes is just a quick little axes like this, and an A, S, T, C. That's all you need. Okay. So technically that represents axes, and the letters are located in each quadrant. So quadrant 1 has an A, quadrant 2 has an S, quadrant 3 has a T, and quadrant 4 has a C. What those stand for: A stands for all, S stands for sine, T stands for tangent, and C stands for cosine. So it stands for our 3 basic trig functions, plus A stands for all. I like to think of this little chart as a big plus sign instead of an axis. This tells you what functions are going to be positive where. When we see an A in quadrant 1, it means all 6 of our trig functions will be positive in quadrant 1. When we see an S in quadrant 2, it means only sine and its reciprocal are positive in quadrant 2. Everything else is negative. When we see a T in quadrant 3, it means only tangent and cotangent are positive. Tangent and its reciprocal, everything else is negative. And finally, in quadrant 4, only cosine and its reciprocal are positive. Now, our last example was a quadrant 4 triangle, right? So look back at those numbers. Do you guys see that cosine and secant, its reciprocal, were the only 2 that were positive? All the other 4 trig functions there were negative. So this is a good way to check those type of problems. It's also a good way to figure out what quadrant things are located in if you don't have a point like this one. This says if sine of theta is greater than 0 and cosine of theta is less than 0, in which quadrant is this going to lie? So if sine of theta is greater than 0, that's just a really fancy way of saying sine is positive. So that should narrow it down for me. If I know sine is positive, only 2 quadrants is where that could happen at. What 2 quadrants is sine positive in? A and S, right? Okay, so it's either there or there. Everything's positive in quadrant 1, and sine is also positive in quadrant 2. I also know cosine is negative from this information. So if I've narrowed it down to 1 and 2, and I know cosine is negative, am I in 1 or 2? It's got to be in quadrant 2, because in quadrant 1, cosine would be positive. Everything's positive. Does that make sense? Okay. So let's do this problem. So this is kind of putting those 2 pieces of information now together that we've talked about. Here we're given that tangent is -4/5 and cosine of theta is greater than 0. We're going to find the exact values of sine and secant. You technically really could find the values of all of the trig functions here. We're just asked for sine and secant though. Okay. So here we don't have a point to draw our triangle with, so we have to figure out what quadrant it's in to get that point. Tangent is negative and cosine is positive. If cosine is positive, what two quadrants could you be in? It's either going to be 1 or 4. Everything's positive in quadrant 1 and cosine is also positive in quadrant 4. If tangent is negative, what quadrant am I in? It's got to be quadrant 4. All right, so that's going to help me draw the picture I need. Just draw an arbitrary point in quadrant 4, kind of like what we did. Take that point, connect it to the x-axis. That's your right angle. Connect it to the origin. And at the origin, that's where our theta is going to be that we're going to use. From there, we can label sides. We don't have a point, but we have the tangent. Tangent is the ratio of what two sides? Opposite and adjacent. So opposite, 4, adjacent, 5, and this is where you have to kind of think a little bit. If you have a negative fraction, either the numerator or denominator is negative, and you're going to use the picture to figure out which of those is true, because you won't always necessarily know. Based on that picture, is the 4 negative or is the 5 negative? The 4 has got to be negative, right? Because if I have a point, that point would be 5, negative 4, if I end up down in quadrant 4. Yeah? Okay, what's the other side? 5 squared plus 4 squared gives me 25 and 16. It's a lot of mental math. 41. Will that hypotenuse ever be negative? No, just Pythagorean theorem, right? So anything squared is always going to give us a positive. The only negatives you're ever going to have are on those legs. All right, once you have the picture, you can find any trig functions they're asking for. Here we want sine and secant. Sine is either opposite over hypotenuse or y over r, however you want to think about it. Negative 4 over rad 41 in this case, which is negative 4 rad 41 over 41. Okay. Secant is your reciprocal of cosine. Cosine is adjacent over hypotenuse. So if I want secant, hypotenuse over adjacent, I just flip it. Rad 41 over 5. Okay? Questions on that one? All right, so just like yesterday in like the word problems that we talked about, when in doubt, when you're doing a Math Excel problem, draw a right triangle. Everything right now is right triangle trig. There is a right triangle hiding in your problem somewhere. If you can get that, you can label sides and you can find anything you need. All right, now this is going to help us get most of the stuff on our unit circle. There's 5 angles that become a little tricky though. And those are all the angles that are located on an axis, 0, 90, 180, 270, 360, because those aren't located in quadrants, they're between quadrants. So we're going to do this together first. We're going to use the alternate definition to find all 6 trig functions for these angles. And we're going to do the 0 degree one first. 0 and 360 are essentially the same thing, right? It's going to be that point over there. If I have that angle, it starts and stops at the same place, right? Its initial and terminal side are both on the positive side of the x-axis. In order to find, oh, we need a different color pen here. All 6 trig functions, I need an x value, a y value, and an r value. And you can use any point on the x-axis to help you. Doesn't matter how far out on the x-axis it is. What do we know about points on the x-axis? Any point on the x-axis has what? They all have something in common. Can we name some points on the x-axis? Would that help? Well, there is a y value. What is the y value? Y is 0. There we go. Okay, y is 0 if we're on the x-axis. The x could change though, right? So we're just going to call the x, x, whatever that is. R is a hypotenuse if we have a triangle. If it's not a triangle, we would just want to think about the definition. It's the distance from our point to the origin, right? That's what it is in all those triangles, the distance from our point to the origin. If this is the point x0, how far is that point to the origin? X. So r is also x here. If you can find those three things, you can find all 6 trig functions. Sine, the alternate definition you wrote down was y over r. In this problem, my y value is 0, and my r value is x. 0 divided by anything is 0. And actually, I shouldn't say sine theta, because we know what the theta is here. It's 0 degrees, or 360 degrees, or 0 radians, or 2 pi radians. It could be any of those. Cosine of 0 degrees, by definition, is x over r. My x value is x, and my r value is also x. If I do x divided by x, what do I get? 1. Tangent of 0, or 360, is y over x, by definition. Y is 0, x is x. If I divide them, I get 0 divided by anything is 0. Once you have those three, flip them, and you get the other reciprocal functions. Cosecant of 0 degrees. Imagine if I flip 0 over x and make it x over 0. X over 0, what's the issue with that? It's undefined, right? The reciprocal of 0 is undefined. If I get 0, that's because there was a 0 in the denominator. If I get undefined, it's because there was a 0 in the or numerator. There's a 0 in the denominator. Okay? Secant is just going to be the reciprocal of 1, which is 1. And cotangent is the reciprocal of 0, which is undefined. And you can write the word undefined, or you can use that. Okay, now you guys are going to do the same thing. I'm going to put you in maybe like groups of 4 to do this. For the other 3 quadrant angles, 90, 180, and 270. Now I will tell you, for some of these, like if you're at 180, you could have a negative coordinate there. Like your x value would be negative if you're on the left side, right? Okay, so you want to keep that in mind. All right, so for 90, 180, 270, you're going to do these with your groups, and then we're going to put answers up on the board. And then we're going to use these values to kind of finish off our unit circle. It'll fill in everything else that we're missing a little bit. All right, groups. Stop this. All right, let's check our answers here. All right, so for 90, I've got the picture up there with the coordinate labeled, x, y, and r, all labeled. Remember, r is always positive. And then those are your 6 trig functions. Remember, 0 and undefined are reciprocals of one another. One of them 0 is in the numerator, and the other 0 is in the denominator. Okay. Questions on those ones? Did you okay? All right. The other 2 are where you could get some negative values, because when we go to the left and we go down, we have negative coordinates. Like here, the x is negative for 180, and here the y is negative. So you might want to check some signs on those ones. But you're going to see a lot of 1s and 0s and undefined when you do these. Okay. So these are the only ones that you really have to use those alternative definitions, because we can't draw a right triangle when we're on an axis and get opposite, adjacent, and hypotenuse. All the other ones you should be able to draw your triangle as long as it's within one of the quadrants. Okay? Questions on any of those? You okay on these? Yeah? Okay. I've just got one more definition for you today. And I did put in here too, if you want it in Polaris, by the way. This chart has like everything we've got in our notes so far. If you want like a quick reference to find something, it's got all of the quadrant angles at the top that we just did. And then it also has 30, 45, and 60 that we did in the last section. They'll be on our unit circle after tomorrow though. Okay, last definition is a reference angle. So reference angles are like that little theta prime I drew in that first example today. It's not our original rotation, but a reference angle is useful because its trigonometric values are equal to the larger value, or the larger rotation. Now there's a lot of different pictures here for each quadrant. What you need to remember is that a reference angle is the rotation to the x-axis, and it will always be an acute angle. So if you have any angle in any quadrant, all you have to do is figure out how far do I have to rotate to the nearest x-axis, and that is your reference angle. Now, it could be in degrees or radians. If the problem is in degrees, your answer should be in degrees. If the problem's in radians, your answer is going to be in radians. Okay, so we're just going to do 3 of these, and then that'll wrap it up for us for today. We'll do the unit circle stuff tomorrow. All right, so let's say I have 175 degrees, and I want to know what its reference angle is. If you want to, you can draw that picture. 175 is going to be in what quadrant? It's going to be in quadrant 2. It's going to be pretty close to the x-axis, right? So that original theta looks like this. If we draw it in standard form, starts on the positive side of the x-axis, rotates counterclockwise. Your job is to figure out what's that theta prime. It's the distance to the x-axis. So if I'm at 175 degrees, how far away from the x-axis am I? 5. And you can get fancy with it and say, if it's in quadrant 2, it's always 180 minus the angle that you have, or pi radians minus the angle you have, or you can just draw the picture and see it, okay? The next one is 5 pi over 3. Do you guys remember what quadrant 5 pi over 3 is from the circle that we did before? It's in quadrant 4. Yep. Okay, so it's going to be something like this. That's my original theta. So we've got to find theta prime. So in this picture, I'm just trying to figure out how much am I short of a full rotation? Well, what's a full rotation in radians? 2 pi. So I've just got to figure out what's the difference between 2 pi and 5 pi over 3. And when I say the word difference, what calculation are we doing? Subtraction. So it's just 2 pi minus 5 pi over 3. Now, in order to do that subtraction, what do I need? Common denominator. So 6 pi over 3 minus 5 pi over 3. The reference angle is pi over 3. Okay. You could also, if you want to, I wouldn't recommend this. If you don't like the radians, you could convert it to degrees. So you could multiply by 180 over pi and figure out that this is 300 degrees. Then you can figure out, well, that's 360, so it's 60 degrees away. And then you have to convert back to radians to pi over 3. You don't want to take every problem we do the rest of the semester and convert back. Even though you're more familiar with radians, with degrees, it's going to be much easier to practice with the radians because this is going to become second nature the more you do it, and it's going to save you a lot of steps in the process. Last one, 3.82. There is not a degree symbol there, which means it's what? A radian. Now, you know certain radians, right? 0 is on the right side of the axis. What's a half rotation? What radian is that? If I'm on the left side of the x-axis? Pi. And the number pi is what number? 3.14. So can you guess where 3.82 is going to be located at? It's going to be in quadrant 3. Okay. So there's 3.82. There's my theta. My theta prime here is there. It's my distance to the x-axis. So what subtraction do I need to do? 3.82 minus 3.14, which is going to give me 0.62 radians approximately. That's it. Okay. So tomorrow, we're going to take all these values we have and reference angles, and we're going to get them all on your unit circle. So you need to make sure you bring your unit circle that we started filling out already. And then we're going to start answering questions with our unit circle to get ready for your first quiz, which is coming up on Tuesday next week. We'll review together on Monday for it. All right, and then don't forget 5-2 Math XL is due tomorrow night. That's your next deadline.